Hello dear students, in this lesson we are going to talk about the laws of indices. The laws of indices are a kind of rules and regulations that we often use to combine and expand different exponential terms. So we have lots of rules, we'll discuss them one by one. First, take a look about how many rules we're going to discuss. So there are about 7 or 8 rules that we'll be discussing in this lesson. Let's begin with the first rule, which is called multiplying indices or product law of exponent. So students, let's say we have two exponential terms. They both have the similar basis. For example, we have a and a, so they both are similar in both the terms. And now we can consider exponent of the first term to be m and the exponent of the second term to be n. So in that way, students, we can write this in the simplified form, which is a raised to the power of sum of both the exponents, which are m and n. Now you have to just write the base only for single time, and this is the simplified version of this expression. We'll have an example, then it will be clear. Suppose we got an expression over here which is 8 raised to the power of 3 times 8 raised to the power of 4. So students, if you don't want to apply any rule in that, what you would do, you will simply expand that. Say for 8 raised to the power of 3, we can write that as 8 times 8 times 8. We multiplied 8 for 3 times. And again, we have to multiply 8 raised to the power of 4. So now we can do it in the simpler manner, like we expand them like that. And then we count, okay, 3 and 4, basically they are good for 7 times. So the combined or exponential form must be 8 raised to the power of 7. But every time we don't have these kind of pretty easy numbers which we have to combine. Let's say we have a very large number and we still need to simplify that. So in that situation, the law that we discussed will be used. What we can do instead, we could have considered 8 raised to the power of 3 times 8 raised to the power of 4. Just because they've got the same basis, we need to just write the base for single time, and then we need to add their exponents. So that's gonna be 8 raised to the power of 3 plus 4, that's again 7. So this is the simpler way of multiplying indices or applying a product law of exponent. We can have a couple of more examples. Let's continue with an example where we don't have any other coefficient, means coefficient is 1. So the idea is similar, that you have to rewrite the base only for once. Now whatever exponents you have, you simply have to add them. That's the easiest task. You can see it's again a raised to the power of 7. But in certain situation you might get terms together with some coefficients which are other than 1. So no problem, do one thing, keep the coefficients aside. We can multiply coefficient to the coefficient, and we can now keep the algebraic term, means the variable term, together. Means a raised to the power of 3 can be written together with a raised to the power of 2. Now the same idea, we have to multiply constants as usual, 28, and now these two terms are kind of where we can apply the law of indices, which is multiplying indices law, where we have got a raised to the power of 3 times a raised to the power of 2. So we simply have to write down a for single time. Okay, so we just write a, and then we need to add the exponents simply. So we get the answer as 28 times a raised to the power of 5, and that's your answer. Let's take one more example. Sometimes we may even have negative indices. So the rule is still similar, that okay, let's first of all keep your coefficients aside. Now it's time to consider your algebraic terms, which are a raised to the power of negative 6 times a raised to the power of negative 2. As usual, you have to multiply the coefficients as it is, but now considering this exponential term, we again have to use the same law, that we need to write the base only for single time, and we need to add the two exponents that we have. Make sure to use the same signs which we have, negative 6 and negative 2. So then after, we have to simplify this. We get 63 times a raised to the power of now negative 6 and negative 2. When we remove the parentheses, that remains negative, and that becomes negative 8. So this is how we get this answer. That's it in the question. Let's continue. Again, we can have some algebraic indices. This time, students, we can have the same thing, no matter whether we'll be able to simplify them or not, but at least we should try to write them in the same addition format. So the first thing we need to do is to separate the coefficients. Now the main target is our variable terms, which are in the form of exponents a raised to the power of 6b, and the other term we have is a raised to the power of negative 7b. They contain the like terms, so definitely they can be simplified. But before that, let's multiply their coefficients. There is no problem. And then after we have got these exponential terms, so we need to add the two exponents that we have. The first exponent is 6b. The other exponent we have is negative 7b. Now we have to perform simplification. So you guys know that we get negative 12 times a raised to the power of 6 minus 7 is just minus 1. We get minus 1b. So we can write it like this. So minus 12 times a raised to the power of minus b is the answer. Let's continue with the next rule, which is called dividing indices or quotient law of indices. Just like students, we used to have same bases and we had multiplication sign in the middle. So we used to perform addition with the exponents. Now the same situation, we have got the similar basis, say a raised to the power of m. And now we have to divide a raised to the power of n. So we need to write down the base only for a single time. And this time, instead of performing addition, we need to subtract the denominator's exponent from the numerator's exponent. So students, concept is still similar, that either we can expand them first and then go for simplification. For example, we have got 8 raised to the power of 7 divided by 8 raised to the power of 4. So instead of applying any rule, we could have done this thing that, okay, we have removed first 8 with this, second 8 by this one, third one by this, and so on. And now we are left with a total 3 8s. So we can write the answer as 8 raised to the power of 3. But instead of doing this method, students, we can apply the law of indices. That's it. We have 8 7th over 8 raised to the power of 4. So instead of performing expansion and then going to cancel them, it's simply you have to do subtraction of the exponent, and that becomes 8 raised to the power of 3. So this is how we can apply the quotient law of exponents or dividing indices. Let's now consider a few more examples. Suppose we have got simple pure algebraic terms with no coefficient. So that's the idea. It's very simple, just like we discussed. We simply have to write the base only for single time, and then we can separate the powers. So we get 8 raised to the power of 3. Sometimes we may have different coefficients, so either you can directly divide them or we can write them as a fraction. There are many ways to represent the exponents in that way, so you can even directly cancel them out here. Let's say 7 goes in 21 for 3 times. So keep your 3 aside, and now the main term we are left with is a raised to the power of 9. So this is your expression where you're going to apply the law of indices. It's going to be a raised to the power of 9 over a raised to the power of 2. So instead of performing expansion and all, you can directly apply the law of indices. That is, you have to subtract the exponents. That's 9 minus 2, and that's simply going to be 3 times a raised to the power of 7. That's your answer. Let's continue with the next question. This time we have got again negative indices, so no problem, the concept is still same. No matter if there are different coefficients present, we can simplify them separately. Our rule will be applicable only on the exponential terms. So before performing simplification with the exponents, let us now first of all cancel out these coefficients. So 9 goes in 18 for 2 times. Keep it aside, that doesn't matter. Now the main task is to apply law here in that expression. So students, you have a at both the places. It means it's the same base. Now you have to perform subtraction. This time you have to be careful because the exponents themselves have some negative signs. So it's better to keep them in the parentheses. And when you open the bracket, see what happens. We have negative 6, negative, negative become plus. So the resultant sign will be whatever that you get after opening the bracket. You get then a raised to the power of negative 2. In this question, we have some algebraic expression as an exponent. So no problem, we can still do the same thing. First of all, let's rewrite them in this fraction format. That will give you the better view. And we then have to perform simplification. So 10 and 100 got cancelled, that doesn't matter, it's negative 10, where we have a, and now we have to perform simplification. We need to subtract the exponents. We get this, and then after we have to open the bracket, that becomes positive. So the answer is going to be negative 10 times a raised to the power of 13b. In this question, we are given the fractional exponents. The font is very tiny. Let me just rewrite it. We have x raised to the power of 4 over 5 divided by x raised to the power of 2/3. So students, the concept is still similar. The bases are similar, so we have to perform subtraction with their exponents. Now no matter whatever exponents are, based on that we have to simplify them. We may get the least common denominator here, which is 15, and based on that we need to change the numerator. So 4 get multiplied to 3, 5 get multiplied to 2, and then finally we have to simplify them. It becomes x raised to the power of 12 minus 10 over 15. That's going to be 2 over 15. So x raised to the power of 2 over 15 is the answer. Let's continue with the next rule, which is bracket with indices. That can also be called as power of power or whole power of a power exponent. Either way you say. Concept as students, let's say you have an expression or a base like a, and it already has some exponent. Now if you raise another exponent over that, let's say this is n. So what we have to do, we simply have to multiply the exponents together, that is m times n. For example, let's say we have x raised to the power of 3, and then again I have got another power, let's say 5. So we simply have to rewrite the base only for once, and then we can multiply the exponents. So we get x raised to the power of 15. That's the answer. These questions are again simple. We have to just multiply their exponents as they are back-to-back exponents. We get 5 raised to the power of 6 here. Here we have 2 and 4. So based on the rule, we have to simply multiply them. Let's have a few more examples, students. Let's say we have an algebraic term, means we have some variable term as a base. As far as there is no coefficient other than 1, we can still apply the same rule, which is 3 times 4 here, because the powers are multiplied. Over here we have 4 times 5. That's okay. But students, sometimes we can have a few questions where we have some coefficients in the base. In that situation, we need to discuss a few more rules. Those rules we'll discuss in the next class. See you then. Bye-bye.